function equation here. And first thing that you have to do, no matter what kind of problem that you're given with, you have to verify the parts that you can factor further. So I do see the denominator side is factorable. This is trinomial. X squared minus 5x plus 6 is obviously the factorable part. So I will go ahead, factor first. Okay, then the numerator is already simplified form, so x minus 3 stays there. Then the denominator is x squared minus 5x plus 6. So now I have to come up with two numbers, multiply to be positive 6, add it to be negative 5. So then 1, 6 is not working, and probably it's going to work with the 2 and 3, yeah. Then for sine y, I have to make both negative so that I can add them, it's making negative 5. Multiply them, it's making positive 6. So in that case, I will have two parentheses with x and x. Two numbers aligned in 2b each side of the parentheses. And then now I'm here. Then once you factor it, in second step, recognize any common factor from top, from bottom, so that you can cancel them. Here I happen to have the factor x minus 3 here on the bottom and top. So now I can cancel x minus 3 and x minus 3 entirely at the same time, so that I can have this simplified form. When I cancel this factor, there's no other surviving factor, and what I have invisibly before there is 1. Then now I copy the surviving factor in next step, so now I have 1 over x minus 2. So then first key features for you guys to get is asymptote. Then there's two asymptotes always that you get. The first, you have to find the vertical asymptote here. I used to have two factors on the denominator, but they canceled. So now I look at the surviving factor on numerator and I will figure out the vertical asymptote from there. Then now the factor that I have on the denominator currently is x minus 2. So now I set this x minus 2 equal to 0. Then I solve as I usually do. Then x is 2. So then this is the vertical asymptote. It's a vertical line passed through where x is positive 2. So then now I'm done with the vertical asymptote. Then the other asymptote that I have to find is the horizontal asymptote. Then now I will go back to the original equation here. So then what I focus looking at is the degree of each side. The leading term of the top is x. Then this x has the degree of 1. Then the leading term of the bottom is x squared. So then this is the degree of the numerator here. Then degree on numerator is 1. Degree on denominator is 2. Then this determines this whole fractional expression as bottom heavy. Literally, the degree on the bottom is greater than the degree on the top, so we just call it bottom heavy. So if your original the rational expression came as the bottom heavy type, it's always gonna get you the horizontal asymptote being y equals 0. When you recognize the whole structure is a bottom heavy. Okay, then now I have two key features, vertical asymptote and horizontal asymptote. So bottom heavy structure gives you the idea about horizontal asymptote. It's always going to be y equals 0, which is x-axis. Okay, and now two key features here. Then there's one more. Because we happen to cancel x minus 3 top and bottom. So we came up with this simplified fraction here. But this is not the same with the expression that we originally given with. So there must be some difference between originally 1 over x minus 2 and originally x minus 3 over x squared minus 5x plus 6. So then when you happen to cancel same factor top and bottom, that always gives you to have whole. So now this cancellation part will give you the position of whole that you can put it on directly on your graph on the curve. So then the factor that you cancel is x minus 3 and set it up with a 0. Then solve it as normally you do. Then x is 3. Then this is the x coordinate of the whole here. So now I can put 3 first. Then the way that you can find the y coordinate is you plug this number back in the expression here. So then this is gonna be 1 over, instead of x, you put 3 there, and then minus 2. So it's gonna give you 1 over 3 minus 2 is 1. So it's essentially what? 1. Then y coordinate is what? 1. So once you are done graphing it, you have to remember this concept whole, and then you have to serve this coordinate as the discontinuity. Discontinuity. Okay, then let's graph it. Let's graph it. Okay, now we have 3 key features here. And label it X, label it Y. Okay, then first, I had vertical asymptotes at x equals 2. So 1, 2 here. So this is 2. Then horizontal asymptote is just x-axis. So I will just have my dashed line passing through on the x-axis there. Then now I can do some point testing so that I can have plots that I can connect to see the general shape of my curve there, right? Okay, so then the good idea for us to pick the testing point is around asymptote. So now I can do 3 or 4 or 5. Then let's do 3 here. But I just remembered I already find the position when I have x coordinate 3 before. It was supposed to be 1 here. So I don't have to do the same thing. So it's gonna give you the position there, 3, 1. Then just 1 coordinate is not enough. So I would just do 1 more. Then if I go with 4 here, then I can do this input here. So 1 over 4 minus 2 is 1 over 2. So then 4 comma 1 over 2, half is here. So then look, this is upper right section, 2 coordinates placed there. Then I do have asymptote going on this position, asymptote going on this position. Then it's obviously you have to design your curve in upper right section going this way. As it gets closer to the vertical asymptote, it's gonna go up. And as you go to the right, and then it's gonna getting closer to the axis. Oh, let me admit Brandon. Okay, then now I will have another side of the vertical asymptote to see if I have another part. So then I will use -1 and 0 to test out. Then -1 goes into that simplified the fraction. So it's 1 over. Instead of x, it becomes 1. And then it was -2. And then it will make 1 over -1, essentially -1. So then 1 comma -1 is another plot. Then if I use 0, so it's going to be 1 over 0 minus 2 is 1 over -2. So then it's making 1 of -1 over 2. So 0, -1 over 2 is right here. Then this is exactly the reflection of the other curve up here. And then it makes the perfect reflection over this intersection of 2 asymptotes there. Then now, one more thing that we have to start here is the whole. And now, because we cancel the factors there at 3, then the position of the discontinuity is happening 3 comma 1. Then this is 3 and this is 1. Then I need to have physically the open circle on the position up there. So this is all at 3 comma 1. And then this shows the discontinuous at this part. Then with this, let's do the domain and range here. So then domain for this graph will be from far left, it's getting closer to towards 2. So it's going continuously all the way up to 2. But because of this asymptote, this way it's approach and this way approach will make this continuity at 2. So negative infinity up to 2. To express the discontinuity by putting parentheses in union, another parenthesis with the same position. Then after 2, it was continuous up to 3, So now I have to make another discontinuity at 3. And after 3, there's no discontinuity happening again. So it can go up to positive infinity forever. Then same manner, the range is also from negative infinity. And then now it's getting up to the level of 0. Then it's gonna make discontinuity because of that horizontal asymptote. And then it starts again at 0, but it's only gonna continuous up to 1. So it's 1 because of this hole. Then I stop there, making this discontinuous with parentheses in union. And then after 1, it continuously goes up. And then it reaches the positive infinity. Yes. Um, so essentially the reason why it becomes 0 is you can remember this. Now, when you have fraction 2/5, then this is essentially telling you 2 divided by 5, correct? So then if you remember this, this is also the top, which is x minus 3 divided by what? X squared minus 5x plus 6. Then since these are not just values, these are the polynomial expressions, then we can see the greatness or small, like greater or smaller by the degree. Then here, 5 does not go in 2 at all. So 5 goes into 0 times, right? The same manner, degree 2 goes in degree 1, how many times? 0 times. Then there's no actual division can, yeah, 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 yes, yes. That's what you can remember conveniently. Yeah, yeah. So only if you recognize the heavier degree on the bottom. Oh, then that's gonna be the slant asymptote case. Slant asymptote case. So I will go over another case that has top heavy too. And I already uploaded some videos. The one video that explains 3 different cases. That was the second one on the assignment. You can just go back to watch that too. But hopefully I can just cover the other. So that this is the bottom heavy case then, right? Okay. Okay. And now let's recap about this whole example here. So from the degree from each side, I can tell the horizontal asymptote. And once you have the simplified form, and from the denominator, then I can tell what? The vertical asymptote. And simplifying by factoring side, if there's cancellation of the common factor happens, then I know for sure it's gonna excuse me. Thank you. Okay. The you happen to have the cancellation of the same common factor, then you know for sure there's whole. Then this whole definitely affects your domain and range besides the asymptote as well. So your domain and range will get a little bit more complicated. And just in case if you guys didn't take the quiz yet, and one or two of the problems talks about the domain and the way the multiple choices provided there for the domain and range description is a little bit different from this method, but it's essentially the same concept. So I will just briefly explain what that is. For example, this is just every single number throughout whole horizontal axis, but 2, but 3. Does that make sense? So this can be expressed as all x values, all the x values except 2, except 3. Then essentially this one is just saying the same thing with this parenthesis and union type of the notation. Then what about this? This means every single y, all the real number y, but what? But 0, but 1, right? So then it's gonna be essentially saying y, and then y except 0, y except 1. So if you guys see the different type of expression of the domain, and it's nothing different, it's just, it's kind of like instinctively you guys can get it. Like it's very intuitive. So that's what I wanted to cover there. So then this one was the bottom heavy, and let's do another one here. Okay, so then the next one is which one should I do? Should I do number 7? Oh, yeah. I will do number 7. Okay, then f of x is 4x squared minus 9 over 2x squared minus 2. Then first I have to examine the given rational expression if there's a factorable part. Yeah, I do see some factorable parts here. Then now, with that, and then before, let's talk about the horizontal asymptote cases. So previous one was bottom heavy, but what is the case for this one? The degree on top is what? 2. Degree on the bottom is what? Also 2. So this way, it's not heavy in one side. They're equal. Then, when you have the degree of each side equal, so it's same, then you can verify your horizontal asymptotes being y equals the leading coefficient from the top, on top, the leading coefficient from the bottom, on the bottom. So then y equals 4 over 2. What's 4 over 2? It's essentially 2. So horizontal asymptote for this case, when you have same degree top and bottom, and you just take the coefficient from each leading term and put them in the same position, top on top, from bottom on the bottom, then y equals 2 will be horizontal asymptote. Okay. Then let's factor first. Okay, I hope you guys can recognize this as difference of squares. And this is 4x squared, which is 2x parenthesis squared. And 9 is also the perfect square number. So it's going to be minus. Then now consider it as 3 squared. Then the bottom. First, I can recognize 2 and 2 as a common factor that you can factor out. So it's 2 out in parentheses will be x squared. And if you factor 2 out of 2, it's going to be 1. Then let's focus on each side. If I have one term squared minus the other term squared, then I will follow the difference of squares, 2 parentheses, 2 terms. The first term 2x and second term 3, and first term 2x again and second term 3, then one parenthesis will get plus, the other parenthesis will get negative. So I'm done. Then now 2 was out there, but the part inside of the parenthesis itself gives me the structure of the difference of squares again, because 1 is also what? 1 square. So then now this will be 2 in front of everything. 2 parentheses will be prepared as x and 1, x and 1. Then first one is positive and then the other one is negative. So now I have all the factors top and bottom. But this is not the same with the previous example because I don't have any common factor to cancel. Nothing top is the same with anything on the bottom. So then it gives me different structure for what? Vertical asymptote. Remember at the end of the simplification of the previous example that I only have one surviving factor, that I had one vertical asymptote. It was in positive 2. But here, no cancellation, I end up having 2 factors equally assigned on the bottom. Then I will have what? 2 vertical asymptote. Where? From negative 1 and positive 1. Why? It's the same procedure. So I will do vertical asymptote will be the first factor, which is x plus 1. Set it up with 0. Solve it. Minus 1 will be x is negative 1. And the second factor is x minus 1, set it up with 0, and x is plus 1, and then it gives me x plus 1. So then, vertical asymptote will be at negative 1 and at 1. Then there's no hope. Then I think we can just go ahead and start graphing. Yeah. Oh, 2 doesn't have any variable. Yeah, so, but there's no way for us to solve 2. But we need to solve the factor that includes the variable. Does that make sense? Yeah. Okay. So then, now, but that was a good question. Okay. So then, what? Okay, then now, let's see what happens if we have multiple vertical asymptotes. So then, x-axis and y-axis here, y-axis here. Then now, this is 1 and 2, -1 and -2. Then now let's label vertical asymptote at 1. So now, first vertical asymptote is here. Then second vertical asymptote is at -1. So now it's here. Then horizontal asymptote is at where? Y equals 2. So now it's not on x-axis anymore. Now I have to shift it up by 2, and then it's going to be here. Then it gives us a big question. I only am used to see the basic structure of rational function takes 2 curves in quadrant 1 and 3. But this one divides whole quadrant not only into 4 sections. I have 1, 2, 3, 4, 5, 6 sections. I don't know what to do. I don't even know how I can see my general shape of curve there. But there's a way. As we always did before, I will pick some points and test out so that I can have some plots. Then I can connect those dots, and it will definitely give me accurate shape of the sketch of the graph, right? Okay, so then let's test the points out first. So then it doesn't matter which section that you go first. There's no absolute order, but I'm just curious what happens in the midsection. So then probably I will pick 0 first. Look, 2 vertical asymptotes are at -1 and 1, and this is just a section in the middle between 2 asymptotes. Then it's gonna be some points that I can get so that I can see the shape there. So then here it's a 0. Then I can plug 0 into any of this expression because there's no cancellation going on, and they're the equal amount of the it's exactly same. They look different. But when I plug the numbers, I think the original expression is a little bit more convenient because I can only input ones on top, ones on the bottom, instead of I just input all 4 different places and then just multiply later. Up to you. It should give you the same result anyway. So then I will just use the original before the factor to get the y coordinate. So if I use 0, then 0 goes in here. It's gonna make the first term 0. So then that's simply -9 over -2, which is 4.5. So then now I can tell it's 0 and 1, 2, 3, 4.5 here, right? So then 1 in the middle is not enough, so probably I will test another one again. So right next to it is 1, but it's where the asymptote is. So I will pick 1/2, 1/2. Then 1/2 goes back in here. So it's gonna be 4 times 1/2 square minus 9, and 2 times 1/2 square minus 2. Then now I have to do exponents first. 1/2 square is 1/4. 1/4 times 4 is 1. 1 take away 9 is -9. In the same manner here, 1 over 2 square is 1/4. 1/4 times 2 makes it 1/2. 1/2 take away 2 is 3/2 on the bottom. It's essentially -1.5. It's negative. So then this is -8 over -3 over 2 is -8 times -2 over 3, -2 over 3. Then this will be positive, and then it's 16 over 3. So it's 5 and 1/3, and it's a little bit higher than 5. So it's 5 and then 1/3 higher. Then if I pick -1/2 to plug it in, and then it's still gonna give you the same y coordinate. Why? Because it doesn't matter, it's the same, because I do have the squaring. So even if I plug -1/2, it's gonna give you the same result. So then now I know for sure there's another one here. Then with this plot, I can tell my graph assigned between two vertical asymptote will go this asymptote behavior for both directions. There's no other possible way. So then, since I do have this graph on top, I would not have anything on the bottom, because if I have another curve going on here, it doesn't make any function because it's not gonna pass the vertical test, vertical line test. So now I'm done with the middle section. So this is only curve that exists on middle section. Then now the way that you can find the right side of the first vertical asymptote or left side of your vertical asymptote is the same. You will pick the testing point and then have the plot. So it's a possible I have another curve in here or there. Then we will see what happens when I test the point. So then if I test, so this is 1, and then I can test the 2 or 3. Then if I test 2, then 2 goes in here. So then 2 squared is 4. 4 times 4 is 16. And 16 minus 9 over 2 goes in here, the 4. 4 times 2 is 8. Then it's 8 take away 2. So then once you plug 2, then it's gonna be 1. Then when I plug 3, then later you can calculate on your time, then you will see it's gonna be at 1.5. So then with these two plots, then I can make my graph getting closer to horizontal asymptote that direction. and I make my graph get closer to vertical asymptote that direction. And the same procedure, just to save the time on the video, I'm just gonna show the next step really quickly. Then you can verify this procedure on your time by plugging all the numbers. Then once I pick -2 and -3, then it's gonna give you this plot, -2 and 1, and -3 and 1.5. And now you can have another graph there. So then this is the complete graph with multiple asymptotes, vertical asymptotes. Okay, then the domain will be -infinity up to -1, and there's discontinuity, -1, and -1 to 1 is continuous, but at 1 I have discontinuity because of the vertical asymptote, and then 1, and then it goes forever. Then for range, then I can start from the lowest point, -infinity, and then it continues up to where the horizontal asymptote is at 2. Then it's not really starting right after 2. There's nothing going on until 4.5. 4.5. So it's going to be 4.5. And after that, it continues up to positive infinity. So this is domain and range that you can provide for this. Okay, any questions so far? Good. Then I think we have a little bit more time for me to go over one more case to figure out the horizontal asymptote. The first one was bottom heavy. The second one is the same degree top and bottom. Then now let's do quickly the example of top heavy. Top heavy. Oh, here's the good example. So top heavy. Then this is f of x equals, the top degree is 2, x squared minus 2x minus 15. And then denominator is x plus 3, x plus 3. So then you can obviously see the degree on top is 2. Then the highest degree on the bottom is what? 1. So then this is top heavy. Then when you see the structure with the top heavy, and actually there's no horizontal asymptote, but slant asymptote will be given, slant. Then usually the slant asymptote will give you this idea. And one of the functions that we studied is linear function. The linear function is a straight slanted line based on this format, y equals mx plus b. It does have slope, and then it's slanted, right? So you expect to have this one here. But not like previous examples, the way that you get this equation for slanted asymptote does not automatically from just looking at it. You do have some procedure to find it. Okay. the procedure is this. As I mentioned earlier, this is essentially fraction. Then whatever you have top is getting divided by the bottom. Then we literally divide the polynomial on the numerator by the polynomial in the denominator. Then how do we divide polynomials? Yes, you need to use what? Long division. Okay. So then, in this case, the long division that I have to do is x squared minus 2x minus 15, and then divided by x plus 3 here, x plus 3 here, right? So then, now I have to have x on top, because x times x makes x squared. So then x times x is x squared, and then 3 times x is plus 3x. Then now I have to change the sign, because after you make the product here, you have to subtract it. So that I can cancel this. Then now this will make what? Negative 5x, negative 2x, negative 3x, and negative 5x. And then I bring this down, negative 15. Then now with x minus 3, I have to have negative 5 there, negative 5. Then this will be x times negative 5, negative 5x. 3 times negative 5 is negative 15. And if I just change all the sign by subtracting it, and then it makes 0. Then once you have this denominator 0, and this is very convenient case, that you can look at the quotient, and that gives you the slanted asymptote. So then in this case, my slanted asymptote will be y equals x minus 5. Y equals x minus 5. This is my slanted asymptote for here. And another way to find this one is also this. And because we focus on how to verify the horizontal asymptote first, and then we didn't really factor this out, then you will see amazing procedure here. Then if we were factoring first, this is two numbers multiplied to be negative 15, added to be negative 2 will be two number x and x, 3 and 5, plus and minus. And then the denominator is x plus 3. Then I get to see the same common factor, top and bottom, to cancel. So then let's cancel. Then what's left? Only x minus 5 on top. So then after cancel, this becomes 1. And then this is essentially what? X minus 5 over 1 in itself. And then this one is actually the one that we found as the horizontal asymptote. Yeah. But it's not going to be directly like this for every single one, because this one has just happened to have 2 and 1 here. So once I divide it, and then the result is just only degree 1. But you might have degree 5 on top and degree 2 on the bottom, and then it gets a little bit more complicated. Then, but still you will have this linear function equation to have your slanted line as asymptote. So that's the difference. So then top heavy, I'm not going to have horizontal asymptote, but slanted asymptote. The way that I figure out the slanted asymptote is that I have the division going on, top and bottom. So then here, essentially, this is over 1. I don't even have any variable on the bottom, so that I would not have any vertical asymptote for this. I don't have any vertical asymptote. That's why on the